So this is two population tests, dependent samples, part 2 of 2. To review from last time, recall that each observation in one sample has a partner observation in the other sample. One observation's value depends on its partner's value. There is a connection there. And the only data that we care about, really, is the difference between these pairs of observations. So let's begin with the equation. Note a couple of things here. We are using a t-test. So this is going to be the t-value. And this is going to be the average difference between the before and after. That difference is what matters. We subtract off our hypothesized difference, it's typically going to be 0. And we have a standard deviation of our differences of the sample. So note, this is why we have to use the t-distribution, because we have the standard deviations of our differences. We don't have a population standard deviation. And here is n, which is the number of differences we have. This should probably be a d bar, not an x bar, but it's the same basic idea. So here's some hypothetical data for weight loss pills. It's all measured in pounds, 149 pounds before, 144 pounds after, and so on and so forth. You can do auto subtraction. Note as well, to continue on the theme from last time, we only have 14 pairs because 2 people dropped out. You can do the subtraction yourself. I'm going to do it for you really quickly. I'm really fast. So when you take all these, when you add all these together, and then you divide, you can get an average. So let's get our average down. With this in mind, our d bar, our average difference is 3.5 pounds lost, or negative 3.5. You can run the numbers on standard deviation if you want. I'll do it for you. Once again, I'm really fast. 4.43 pounds is our standard deviation. And n is 14 as noted before, because we have 14 pairs. Once again, here's our equation. So we're going to plug them in appropriately. Again, our hypothesized difference is 0. Right? The null hypothesis is going to be there is no difference between having the pill and not having the pill. And when all is said and done, you should get this equation set up. Here's negative 3.5 in the numerator, 4.43 for our standard deviation, and square root of 14 for our n. And I guess technically I'm subtracting off 0 here, but who cares? That's just going to be the same thing. So you can go ahead and pause the video if you want, calculate it yourself, and see if it matches with mine. Okay, let's see if it matches. I got negative 2.95. You should get about that. But what does that mean? So as usual, whenever we get a t-value or a z-value, we need to compare it to critical values. And because it's a t-value, we're going to need to pull up our table. Now the first question we have to ask ourselves is, was this a one-tailed test or a two-tailed test? So typically you assume 2 tails because it's a higher standard. But think about what this is. This is a weight loss pill. Not terribly interesting if the pill results in gaining weight. It's only interesting if the pill results in losing weight. In which case, we're going to look at a one-tail test. So let's highlight all the critical values for a one-tail test. Those are the key ones. 95% confidence, or an alpha of 0.05. 99% confidence, or an alpha of 0.01. And a 99.9% confidence, or 0.001 for alpha. Down here is a two-tail version. We care about the one tail, so we'll care about the alpha here. Now we need to figure out what our degrees of freedom are. We had 14 observations. So 14 minus 1 to give us our degrees of freedom. Degrees of freedom of 13. Here are our 3 critical values of note. I'm skipping over the 90% one. That's kind of a weak one. Let's just do these 3. So we have alpha of 0.05 and 95% of 1.771. 99% or an alpha of 0.01 at 2.65, and an alpha of 0.001 or 99.9% at 3.852. Keeping in mind we have a t of negative 2.5. Now the rule is always when you do this kind of analysis, it's the distance that matters, right? You're going to be comparing the critical values. So you're going to take the absolute value of your calculated value, which becomes 2.95. And at 2.95, we can compare it with our criticals, and you note that it is greater than this value at alpha 0.01, but not greater than this value at alpha 0.001. So it's statistically significant at 99% confidence. It looks like our weight loss pill works. Is it practically significant? Maybe 3.5 pounds. That's something, right? Some people might care a lot about that. That might be worth it. It is just a pill. It depends on the costs and the market research. But from the statistics point of view, it seems to have an effect. Again, it's possible it might not 1% chance of coincidence, but we have some pretty strong evidence. So that's it. Dependent samples. Thanks for watching.